Okay, hello all. So I wanted to set this up because I know that we've been using the force sensor now, and I wanted to do a few things with it just to kind of show the different ways that the force sensors can actually be used. And I know in the discussion there in the Google Classroom, it talks about being able to use it as a Boolean response, as well as just the variable numeric response that it actually gives too. And that's more important in the coding part of the side of things. But right now, I just threw some code in there just to kind of demonstrate what happens with like an event result. So the pressed function itself is just a Boolean response that we can actually get from the force sensor right here. Basically, anytime it's actually pressed, it's actually going to do something. And that block coding that you actually see, it's starting with where it talks about right here, where we have anytime that the sensor itself is pressed, being plugged into the A on the brick there, it's going to have that Boolean response of true. So as soon as it's pressed, it's going to go through this function of code. And I set it in two different events so it can actually operate the motors at the same time. Because anytime that you do this block coding, it actually has to go through sequentially. So if you were to link the blocks behind this, it would go in it would do C first, and then it would do D, or however you had it linked up. But since we have them both linked to the event of A being pressed, they're going to happen simultaneously. So with that being said, at about 75% power, we're going to do 3 rotations on the 2 wheels. And since they're going the same direction, they're actually going to be going opposite. So effectively, we're going to make the robot turn around. So right here, I'm going to press real quick. And you see, each wheel does 3 rotations, which causes the robot to spin around such that it almost does like a 90-degree turn effectively with those 3 rotations like that. Okay, so now I've altered the code a little bit because the whole reason that I set it up like this is I wanted to put the force sensor in front to see if we could have it running forward and then it runs into something and it backs up and turns around. So going to put some theory to test and see if this works. And it went the wrong direction. So hold on. We will test that again. This is the important thing of testing. So seeing that it went forward and then it turned, let's do this instead. We will switch the direction of that. Switch the direction of we're going to simulate hitting. So it does back up and turn, but it turns a little too much. So we're going to have to adjust and figure out to see if we can get it to... Okay, so now after a little bit of tweaking, I think I got it to where I am allowing it to back up, and I slowed down the speed a little bit as well, but I'm allowing it to back up and actually do a 180. So we'll show it again. Yeah, pretty good 180. So now that we have this code, we're going to go on to setting it up to where it's going to run the motor. Then as soon as it bumps into something, it's going to run its turnaround, and then it's going to keep on going. Okay. So now that I made the code and everything, I put in here to show you the automation of the robot if it will work correctly. So when it starts up, it says start your engines, and then it goes. So it hits, turns, comes back this way, hits, turns, so it's not exactly a 180, but it does work pretty well. So one thing I definitely wanted to talk about too is so we do have this force sensor, but it does have the ability to have a variable response. So like if you see there up at the top of your window where you can do your block coding and everything, you can actually see the response of actually as you push on this force sensor, like how many newtons it's actually going through. So like as you depress it, like you can slowly depress it and you feel like it's hard to get 1 newton because 1 newton is kind of tough, but 2 newtons, 3 newtons, 4 newtons, 5 newtons, 6 newtons, 7 newtons, 8 newtons, 9 newtons, 10 newtons. It maxes out at 10 newtons, but you have to put a lot of pressure on it to actually push that plunger all the way down. But it does have the ability to kind of go through that full cycle. Now there are other portions of it. If you look at the shapes of these blocks, this is a Boolean block, and that means that the output of it is either true or false. So basically, it's a digital output. Like it only can be yes or no. So it's yes or no question. So like it being related to the force sensor, right? You have the A, and you can have it selecting pressed. So pressed is basically, is this thing pressed? So just that barely pressed means that once that it's barely touched like that, it literally changes that from a false to a true. So there's also the hard pressed. Now the hard pressed, if you fill it, it means that you have to put some pressure on it to actually change it to that hard press sensor. So the hard press selection is a little bit different because it's not just that bare tap. You actually have to push that plunger in quite a bit and actually get some resistance from it. And then the released, of course, is just the reverse of that. So if it's already being touched and everything, and then there's no pressure on it whatsoever, that's your released portion right there. So those are all the Boolean ones that you can have. But then you notice this other block that is a different shape, and it's got this roundness to it, because that's a variable. So it basically gives you a variable response. So in the sense that it has a variable response, there's 2 that we can actually select there. So you have the newtons, and as you can see that it cycles through 1 all the way to 10. So you can get basically 10 different increments, and then it also has a percentage response to where we can actually cycle through the full percentage, so you can actually get a certain amount of percentage. Anytime you're using an if statement, you need to actually use a Boolean response and actually in order to be able to use an if statement, right? So if we were using an if block, we would have to use one of those Boolean responses to be able to go into the if statement to actually do something. Whereas the variable response is something that we can do a little bit of different information with. So I ran through a little bit more block coding, and I set up this basically some conditionals with these responses, and you can see that the difference is using this variable response, I actually set it to the value of a variable newtons, and then I used it to basically turn it into a Boolean response in patterns, so we could actually cycle through basically the pressure of it, and it will actually change the color of that center light there, okay, as it goes through, and it's also going to light up the light matrix as we kind of put pressure on it. So we'll run the test right now. So as it barely gets pushed, you can see that a couple blocks light up, it turns orange, push it a little bit more, now it's yellow, But you can see, like, you gotta be a certain amount of newtons or a certain percentage. It's actually I think it's set in newtons. So that's yellow, orange, yellow. Then there's the one green. The next green, like teal color. Then it's a light blue. There's another blue. That's the darkest blue. It's like a purplish. It goes to another purple. And then we max out. This is maximum overdrive. And if I keep this held down, it'll keep on doing the maximum overdrive, but as I release it, it still has to cycle through that maximum overdrive, but then it lets you know that now it's resetting. Boom. So now it's reset, the button's red, and we can cycle through it again. So yeah, you don't have to go all the way to maximum overdrive, you can do it a couple. And if you go back, you can see the button color changes. But you have to release it completely. So the Boolean response of released means that it has to be completely released. And then it would actually go back to the point of where it's actually resetting.